machine learning project with respect to loan approval with a specific data. So here, machine learning can be used to classify whether a given applicant's loan can be approved or not. So let's look at the different steps on how we can uh, use machine learning to classify such information, right? So imagine we have a banking system where we are given with a loan applicant's gender, marriage status, dependence, education, and these kind of features. So um, we must need to decide if we can approve this loan or not, right? So this is a typical classification machine learning problem. So let's look at how we do this. So firstly, we are looking at the type of dataset, and the dataset that we are using is loan price prediction CSV. I have attached all of these IPython notebook and also the related CSV file in GitHub. With this video description, you can find that link. Next is we load this data. We have already loaded this data here, and we are understanding what are the different kind of values that are there with each feature, and we start checking if there are any null values and fill them up accordingly with either the numerical ones with mean or the categorical values with the first occurrence of the category, right? So next we understand the data, like what is the distribution of a specific feature or what percentage of male applicants are there. So we see, like we see here, there is close to about and another important factor to consider here is there are about 614 data points, and there are about 114 here and 500 here, so that constitutes to about 500 male and female, close to 100 or so, right? 20% and 80% male. Marital status is another one. Both these adding will give out 614 data points. Like we could also see the other features here: dependents, how many dependents a specific applicant has, and the educational distribution, employed or unemployed, the kind of population a specific applicant is coming from, loan status of the specific applicants. And next is we also see the distribution of income and co-applicant's income. So you can think about co-applicant as applicant and his dependents or spouse, right? And loan amount that he is looking to get from the bank, and the term of for the same amount. Credit history. So with all these, we can quickly get a visual idea on how much of a distribution for different features look like. And next is we can create new attributes or merge couple of attributes to make this uh, one less feature column, like we are doing here. Total income can simply be clubbed with applicant's income and co-applicant's income. So next we had this specific co-applicant's income and applicant's income, which can be better visualized with log transformation, which would make it a lot more skewed and a lot more easy to understand. Same thing goes for this one as well, where we are seeing co-applicant's income, and loan amount also is something that if we log the values, we are able to see the distribution of it. Most of it is in this area between 4 to 6 or the highest of 5. Okay, so those were few visualization things. Next we can talk about the correlation matrix which can help us to identify any two features which are directly dependent on, like loan amount term and loan amount term log. Okay, and loan amount log or total income. See, the total income and the amount of loan being applied is might be directly proportional as well, and applicant income, right? So those are few things. um, so we can identify such interdependent features which where increasing one can also increase the other, like for example an applicant's income will also might also result in the loan amount that he's looking to seek. Let's say a person with 5 lakh rupees income might seek an loan amount of 3 lakhs, while a 10 lakh income person might seek a loan of 3 lakhs, right? So you understand the dependency there. So label encoding is another thing where we can convert certain features which are of categorical type to numerical value. So that's one thing that we are doing here. And next we start out with having to split our data set with train and test splits and start giving it out to the different uh, machine learning models like decision tree classifier, random tree classifier, extra tree classifier, and such things. And then we start having to hyper tune parameters to get uh, the best possible settings. And finally, we can measure the scores and also the best parameter splits that give us best predictions from a machine learning model. So we do that for all the different machine learning models. And finally we look at the true positive, true negatives of the machine learning models results. That's one thing. And next we start being curious with having to test with external data source, right? So that was about it. So we have some data outside the already existing data set, and we predict if we can get a loan for this external data set with the way that we have trained the model, and start making use of this machine learning model. That was about it. Hope you found this video helpful. This was a classic machine learning project example that I wanted to share with you. Hope you are finding this video series helpful. Please do like and subscribe to my channel. We shall continue on this learning journey with next set of topics, with having to understand more on training models, gradient descent. First, we will start off with logistic, uh, lo- the regression model, which is basic logistic regression model, and then we also see gradient descent to help smoothen the parameters or the way that we can train these models, right? So we will look at all of these in the upcoming session. Hope you are finding this video helpful. Please do share any thoughts or the way that we can bring out next set of projects into this playlist. Thank you.